Let's move on. We'll go to the next worksheet. Now here I want to do a quick review about one of Excel's operators that you might not be familiar with. This is the exponents. If you need to raise a number to a power, you have to use the exponent symbol, which is the caret. That's the funny little pointy hat that's the shift 6. So for example, if I enter equal 3 caret 2, Excel will raise 3 to the second power. 3 times 3 is 9. If I edit that and use equal 3 caret 3, 3 to the third power, that's 3 times 3 times 3, is 27. Now let's say that we have a number that's squared. For example, 5 to the second power is 25. To figure out the square root of that number, Excel gives us a function, the square root function, equal SQRT. The square root of 25 is 5. Simple enough. But it's possible to raise a number to a power larger than 2, equal 3 raised to the third power. How do we take the cube root of a number? There is no function beyond square root. There's no function for a cube root or anything like that. The trick is going to require you to go back and remember high school math. Turns out that taking the cube root of a number, that's the third root of a number, is the same as raising the number to 1/3. Watch how this works. Equal 27, the exponent symbol, and then in parentheses, 1 divided by 3, will take the cube root of 27. This works for fourth roots, fifth roots, and so on. Now, it's rare that you're going to have to work with this unless you're the person responsible for figuring out how fast your company has grown. Over on the left side of the worksheet, we have sales figures for year 1 through year 5, and we want to figure out the compounded growth rate from year 1 to year 5. Well, the total growth rate, the formula here in D5, is simple enough. We take the last year divided by the first year and subtract 1 to see that we've grown 537% over the 4 years. But that's a completely different calculation than the compounded growth rate. Compounded growth rate requires you to take a root. In this particular case, from year 1 to year 2 is 1, year 2 to year 3, that's 2 years, year 3 to year 4 is 3 years, year 4 to year 5 is 4 years, so we need to take the fourth root. Take a look at this formula. We take the last year divided by the first year, and then raise to the 1/4 power, and then subtract 1, or 100%. That'll show us the compounded annual growth rate is 59%. It's not often that I have to pull out the exponent symbol in order to figure out complex roots, but this growth rate is one that comes up again and again and again. Let's move on.